adding fractions. The example will be 3 3/4, a mixed number, plus 1 2/5. The method we're going to use here is exactly the same method we would use for subtraction. So first thing, we would estimate. So an estimate here would be 3 3/4. Is that closer to 3 or closer to 4? Is 3/4 a fraction that is closer to 1? Yes. So 3 3/4, we could simply say that's 4. Then 1 2/5. Think about 2/5. 2/5, is it bigger than a half or smaller than a half? It's smaller than a half, because half of 5 would be 2.5, and we have less than that on the numerator of this fraction. So 1 2/5, we could say, well, that's basically not even 1 1/2, so let's call it just 1. So 4 plus 1 will give us 5. That's a very rough estimate, but just so that we know, we cannot get an answer that is in the house of tens or less than 1 anyway. So what do we do? These two mixed numbers are very hard to operate in this form, so we need to change both, and I'll write them here again, to improper fractions. So basically what we do is we start from the bottom and we go around clockwise, doing what? First we multiply. 3 times 4, 12, plus 3, 15. So we have 15/4 or 15/4. We do exactly the same with the other fractions. Start with the 5. 5, go around clockwise. 5 times 1, 5, plus 2, 7. So we have 7/5. So for all operations we do with fractions, with mixed numbers, it will always be easier if we change them to improper fractions. So that's the first step, always change the mixed numbers into improper fractions. Now, because we are adding, or in the same case if we were subtracting, we have to look at the denominators and check that they are the same. They are not. So we need to find the lowest common denominator here, or the lowest common multiple between 4 and 5. So one thing that we can do is actually list the multiples of 4 on the side in scrap paper. So 4, the tables of 4, 8, 12, 16, 20, 24. I could keep going, but I'll go ahead if I need more of those. Now I'll do the same with the 5. So family of 5, or multiples of 5, or times table of 5. 5, 10, 15, 20. Oops, I don't even need to carry on. Why not? Because I see straight away that 20 is the first multiple on both lists that repeats. So you could be doing this in your head, but there's nothing wrong with doing it in writing, in scrap paper, or even in the space provided for you to solve this question. So here, the lowest common multiple, or the lowest common denominator in this case, will be 20. That means the 4 needs to be multiplied by what number for us to get to 20? Well, you might know straight away it's 5, or else you will count here. 1, 2, 3, 4, 5. So multiply that 4 by 5, but if you do that, you must do exactly the same to the top of your fraction to keep that proportion. So once we do that, we can rewrite this fraction as 5 15ths, 75, if we know straight away. Otherwise, we would say 5 10s are 50, 5 5s are 25, 50 and 25, 75. And 4 5s are 20, as we already knew. So now we need to rescale the second fraction. Well, 5 times what will give us 20? You might say straight away 4. If you don't see straight away, you count 1, 2, 3, 4. 4 5s are 20. So multiply top by 4 as well, so that your fraction keeps that same original proportion. So what we get? 7 fours, 28. We need to know our tables. 5 fours, 20. Now, the two denominators are exactly the same. That's what we need when we are adding or subtracting fractions, because now we are talking in 20ths, size 20th for each of those parts that we have actually got in each whole of the fractions. So what we do here, we are going to keep that 20 because we're talking in 20ths, and we are just going to add the tops because we have 75 of those plus another 28 of those. So doing the calc here, we can do that in our heads. 70 and 20 is 90, and 5 and 8 is 13. 90 plus 13, 90 and 10 is 100, plus that 3, 103. This is the answer, but it doesn't look easy to picture. So what we need to do, because the top is heavier than the bottom, it's bigger, so that means we can have 20 into 103. So that's the key question. How many 20s go into 103? Because this is an improper fraction. We want to see it in a way that it's more meaningful. So thinking about that, so 20 times what? You could think 10 20s is 200, but that's way too much. So 5 20s will be 100, which is exactly good. So we're going to say 5 whole 20s is 100. What's left? 3. And we keep that 20 because that's the size we're talking about. So 5 answer, 5 and 3 20ths. Look at our estimate. On the top there, we had 5. Of course, that estimate is just an estimate, but our accurate answer is 5 wholes and 3 20ths.